Before you start watching this video, I want you to make sure that you fully understand what relative minimum and maximums are. So we are going to build on top of that. I'm going to introduce absolute extrema, which is absolute maximum and absolute minimum. So what is absolute maximum? Absolute maximum is the highest value compared to the points within a closed interval. So you have a function. So let's say f of x equals to 2x to the third minus 6x. And then I have a closed interval at -2 to 2. So we have a graph. So what we are looking for is I only need the piece where x goes from -2 to 2. And then within that piece, tell me the point that has the highest value and also tell me the point that has the lowest value. So the highest y is called absolute max and then the lowest y is called absolute min. So I have three graphs for you. So we say that function f is a continuous on a closed interval. And then the first graph, I have the first graph right over here. So the first graph on a closed interval starting at this point and then we go up and down and then up. So where is the absolute max? The point on the right. So this point is called the absolute max because compared to every single point on this graph, this point has the highest value. And then this point is called the absolute min because compared to all the other points, this point has the lowest value. And then what about relative maximum and relative minimum? So for relative min and max, so first of all, how do you find a relative min or max? You have to take the first derivative and then set that equals to 0. The reason we have to set that equals to 0 is because we want to find the critical number, and other than that, we set that equals to 0 because we want to find horizontal tangent line. So we have a critical point, and then when the slope is equals to 0, you have a horizontal tangent line, right? And then you either use second derivative test or you use the first derivative test. So for relative minimum, you have to show that the slope before that point, the slope is going down and then you reach to 0 slope and then go back up. So this point is a minimum, right? And then on the other hand, so if the slope is going up and then going down, then the critical point is a relative maximum. So that's how you find the relative max and min. Either you use the first derivative test or you use the second derivative test. But absolute extrema, the max and min, they are much easier than this. All you have to do is you plug in every single value to the given function to find out the highest y and the lowest y. Okay, so let me go over these three graphs and then I will give you an example. So the next graph, we have the graph right over here. So the point starts at this, the curve starts at this point and then go up, down, and then up. So this point is clearly having the highest value. So this point is called absolute max. And this point has the lowest value. So this point is called the absolute minimum. And then other than that, we have relative maximum and then relative minimum. So to find out these 2 points, this curve can be represented by a function, right? You take the first derivative, set that equals to 0, and then you will get 2 critical points, one at here, one at there. And then you set them equals to 0, you get critical points, and then you have to either use first derivative test, which is the sign chart, or you use second derivative test, and then you will see that this is the relative maximum and then this is the relative minimum. And then the last graph is pretty much a very special case. So we have a curve between this spot and this spot, right? You can call this A and then call this B. So we have a function f of x, and this function is defined on a closed interval a to b. And then where is the absolute maximum? So we have 2 absolute maximum, one over here, one over there, because at these 2 points between A and B, so between A and B, these 2 points have the highest value, right? So this point is the tallest, all the way up, tallest, has the highest value. So I call them absolute maximum. And then these 2 points, they have the lowest value right over here. I call that the absolute minimum. And then what about relative min and relative max? Easy. You take the first derivative, set that equals to 0, and then you will get 4 critical points. So 1, 2, 3, 4. And then you use a sign chart to test each critical. And then you build your test interval, and then you put that on a sign chart, do the testing, and then you will see going down and up. So you have a min, up and down you have a max, down and up you have a min, up and down you have a max. So every single point has two names. So this point has two names. This point is called absolute max because this point has the highest y value, and this point is also called the relative max because I just use a sign chart to show that this point is a relative max. Same thing for the other point. So if you have a function defined on a closed interval and then you have a point, so that point can have two names. So either relative and maximum min or relative and absolute max. All right, so let me give you an example. So to explain each case scenario, so I have f of x equals to 2x to the third minus 6x, and then I am only concerned when x is between -2 and 2. So on the graph, you can clearly see that when x is equals to -2, we are right over here, right? So when x is equals to -2, so this is a -2 comma -4, and then when x is equals to 2, we have 2 comma 4. So we only need this piece. Up and down and then up. So this is the piece that I need. Now let's find the critical number. So first of all, we take the first derivative. So we have f prime of x, very easy, take power rule. So that is 6x minus 6. And then you set the first derivative equals to 0. So factor a 6 out, we have 6 minus 1 equals to 0. So x equals to what? X equals to, oh, this is a square, x square. And then you can do one more factor. Let's write this one more time, square. And then square, so you have 6x plus 1, and then x minus 1 equals to 0. So x is equals to -1 and x equals to 1. So what are these called? These are called critical values, right? So critical values. So you have critical values, and then the endpoint is x equals to -2 and x equals to 2. All you have to do is you test them. So let me build a little table right over here, so to test them. So the table that I'm going to build is this. So we have x, and then you drop all the endpoints and the critical numbers down. So we have -2, -1, 1 and 2, and then you plug them into f of x. Again, the highest y value is the absolute max. The lowest y value is the absolute minimum. So when x is equals to 1, this is easy, right? So when x is equals to 1, so f of 1, so that is 2 times 1 to the third minus 6 times 1, so which is 2 minus 6, that equals to -4. And then you do the same plug-in for the rest of the x value. So this one, it turns out that this is a 4, this is a -4, and then this is a 4. So which one has the lowest y value? So the -4 is the lowest y, right? So that means this is absolute minimum, and then this one is also the absolute minimum. And then which y is the biggest? The 4, right? So that means they are both absolute maximum. So absolute max and then absolute max. So the 2 comma 4, this is an absolute max. The -1 comma 4 is an absolute max. So let's verify this using a picture. Do you see that -1 and 2? So this -1 and 2, so this point and this point, so they are called the absolute max, right? And then what about the absolute min? This point and this point, they are the lowest y value within the closed interval, so they are absolute minimum. It is just that easy. All right, so because we already have a function, so let's do a few more cases. So the next one, this time I am only interested from -3 to 3. Again, we already have two critical numbers, so all you have to do is you do the testing. So you draw an x, and then you plug it in. So we go from -3 to 3. So this one, when x is equals to -3 and when x is equals to 3, the graph already go up, and I already cut off the graph, so you cannot really see that point, but we can still find the coordinates. So -3 and then 3, these two are the end points, and then -1 and 1, these two are the critical points. So all you have to do is you do the plug-in. So f of -3, what is that equals to? That equals to 2 times -3. 2 times -3 to the third power minus 6 times -3. So that gives you a negative 36. And then the rest of the points, this is a 4, this is a negative 4, this is a positive 36. So which point is the highest and which point is the lowest? This is f of x. So my conclusion is the negative 36 is the lowest, right? So this is the absolute minimum. And then where is the highest y value? This one is the highest. So this is absolute maximum, right? So if you keep track on the 3 and negative 3, do you see that when x is equals to 3, so the graph goes all the way up, that goes up so high. So that's why 3 comma 36 is the highest y value, and then when x equals to negative 3, the graph goes all the way down. So negative 3 comma negative 6 is the absolute minimum. And then what about the next one? The next one is from 0 to 2. So this time we can pretty much see everything. So from x equals to 0 to 2, we have this piece right over here. And then we do the testing, x and then f of x. Okay, the endpoint, the first endpoint is x equals to 0. Do we still plug in the negative 1? The answer is no, because negative 1, so this negative 1, we do not plug in the negative 1 is not in 0 to 2, so we do not test the negative 1. Forget it. I only want from 0 to 2. If the number is outside this interval, do not test. Okay, so 0, then 1 is between 0 and 2, and then 2, right? So when x is equals to 0, you plug in a 0, right? So f of 0, that is equals to 2 times 0 to the third minus 6 times 0. So that is equals to 0. So this is a 0. That gives you a negative 4. That gives you a 4. So where is the lowest y? Where is the highest y? So this is the lowest y. So that is my absolute minimum. And then the highest y is 2 comma 4, right? Oh, from 0 to 2, huh? Actually, I make a little mistake. So I should extend all the way up. I'm sure that most of you already found this mistake. So this is my closed interval, and then 2 comma 4. So this is absolute maximum. So look at the red pieces. So this is the absolute max, and then this point is the absolute min. The picture just saved my life. All right, one more. Last one. From negative 3 to 1. So from negative 3, the graph went all the way down, so you can't really see it. When x is equals to 1, we have this. So the piece, I should not use blue. Let me use this. So x is equals to 1, x equals to negative 3, and then you can see that this graph goes all the way down, right? So this is the piece that we want. I can pretty much see it. So this must be the minimum, and then this must be the maximum, right? Let's find out. So we have two critical points, x equals to negative 1 and 1. So we have to test this. So negative 3, negative 1, oh, and 1. 1 is also an endpoint. Okay, and then this one you test the f of x. You plug in negative 3 to the original function. You have negative 36, so that gives you a 4. This gives you a negative 4. So this is the lowest y. So this is the absolute minimum, just like what I wrote on the picture, and then this is the highest y, so that is the absolute maximum. Again, this is a point, negative 1 comma 4, and then negative 3, negative 36. So that's how easy it is. You don't need any sign chart, you don't need the second derivative test. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media for me. If you are new to the channel, please take 2 seconds to click the subscribe button. I appreciate your help, and I will see you in the next video. Signing out.